Hi guys, Mr. Sonnenberg here. Today we're going to talk about light sources. So this is for Science 8 students studying light and optical systems. Topic 1 in your textbook for study reference. So this would be a good time to get out a piece of paper and a pen or a pencil and start jotting some notes down as we go through the screencast. But basically we're going to look at both natural and artificial light sources. We'll talk about both. I'll break them down a little bit so that we can better understand what they are, and I'll provide you with some examples so that you can see and understand maybe ways that you've used these particular light sources in your own life or throughout your experiences thus far. So, what is light, or what are one of the light sources? Well, the first light source, we have naturally occurring light sources, so natural light. So these are things such as the sun, candles emitting light, or wood producing fire, and then that fire is emitting light as well. Then we have this last one that's called bioluminescence, and bioluminescence right here. Okay, these are things like this jellyfish producing light, or a firefly. It's light produced by living organisms. Okay, so now just remember that light, uh, if something is luminous, it emits light or it produces light, and if it's non-luminous, then it's not going to produce light. Okay, so we'll just take a quick look at that. So luminous, okay, is going to produce light. Okay, and then non-luminous, it's not going to produce light. Okay, all right. So I'll just put that does not produce. Oh, my writing's messy. Light. Perfect. Okay, so types of natural light that we can see: sun, candles, wood fires, or bioluminescence. And so the sun is our most vast and greatest natural form of light. And remember, it radiates light through waves. Okay, same thing with the candle. It's going to produce radiation, and radiation moves in all different directions, so it's going to produce radiant energy. And then wood and fire is the exact same thing. And then bioluminescence, though, is these living organisms producing that light. So luminous means it's going to produce light. Non-luminous means it does not produce light, and we'll talk about that in the next topics to follow. But those are natural light. But what about artificial light sources? So we have light sources that are artificially occurring. So incandescent. I'll just kind of number these right now. Oops. So incandescent. So let's say we'll talk about that. 2, fluorescent. 3, phosphorescent. And then 4, chemiluminescent. Okay. Now these are artificial, so there's some external source that they need to power. So they need to absorb some form of energy to emit light. Okay. So we'll talk about these and we'll break them down individually. So the first one we're going to talk about is incandescent light sources. So basically what's happening is the heat is causing a filament of metal to glow. So it has this filament, and that filament is actually this metal that follows here. So we have the filament, okay, so I'll just underline it in blue, draw an arrow, filament, but then we also have a base down here. Okay, so the base is going to cause an electrical current to come through the bottom here. Okay, so we're going to take electrical energy in through the bottom and the base, and the heat is going to go up. The heat is going to go up, and it's going to cause this filament to glow. Now when that happens, then it's going to emit visible light energy, because that filament is going to produce white light, and it's going to be extremely hot and produce that white light, and it's going to cause it to glow, but it needs electrical energy. So basically what happens is electrical energy is then converted into heat energy in the filament, which is going to be converted into visible light energy. Now the problem with these incandescent bulbs is they're not efficient, which means that they produce much less light than they do heat. So 95% of the energy is heat, and we actually only get 5% of the energy is visible light. So not very efficient, and they produce a lot of heat. And an example is I had a light bulb when I was constructing my house, and we're pouring the concrete slab in the garage, and so we didn't have anything insulated yet at the time. We had the stucco on the outside, but the garage wasn't insulated, poly or drywalled at this point. So what we had was we clipped on an incandescent light bulb to provide some light, because there was no electricity in the garage at the time. And we left it on all day as we're pouring all day. It was a big slab, and it actually produced very little light to light up the garage, but it produced more heat, and it actually burned through the stud, the 2x6 stud. It burned through the plywood that was sheeting up against the studs. It burned through the 2-inch insulation on the other side, because it produced 95% heat, right? 95% heat and only 5% light. So we didn't get a lot of light from it. Sure produced enough heat to eat through 2x6 wood, 2x4, and plywood and insulation or styrofoam on the other side. So these incandescents, not very efficient, but what we're doing is we're taking electrical energy, okay, in through the bottom, producing heat like this red and this filament, and then emitting thermal energy and visible light energy. Okay, so then the second source we're going to talk about is fluorescent. So fluorescent light sources, okay, basically what happens is we get ultraviolet light that's produced, and it's absorbed by fabric fibers, and then they're excited, and then they emit the energy as light, so they glow. So we take this ultraviolet energy, okay, and energy is absorbed by particles, and then they get excited and produce visible light. So these would be like right here would be like the fluorescent lights in our classroom in the science lab. Here's another example right here. But basically what happens if we were to break one of these down, right at this area here, there's two pins, okay, that look like such. Actually, I'll draw them in red. There's two pins right here, and those are actually going to take an electrical charge, so the electricity. Then they go into a lead wire, which leads to an electrode right here. Now inside this fluorescent bulb, there's actually mercury vapor. Okay, so there's mercury vapor inside. So now that's inside the bulbs here. Okay, so what happens is there's this electrode, and then it's actually going to create UV light or ultraviolet light, okay, when it mixes with the mercury vapor, when the electricity from this electrode right here mixes with the mercury vapor. Now there's a phosphor, okay, there's a phosphor coating that is then excited on the inside of the bulb, that when we create this UV, it's actually going to excite the phosphor coating, and then that's what's going to give us the visible light and the glow. Okay, so there's two pins, or there's a pin on each end, produces electricity and then moves through the lead wire into the electrode, and it basically combines with the mercury vapor to produce ultraviolet light energy. Then that is absorbed into the phosphor coating, which excites those particles and then emits visible light. So that's how fluorescent light sources work. Okay. Now the third artificial light source we'll talk about is phosphorescent light sources. So this is when light energy is stored and then is later released. So these are those things like glow-in-the-dark stars that you can put around your bedroom, or sometimes if you have something that glows and you can put gels on your clothing and such, and then they glow in the dark. And basically what's happening here is, if we just take a look at some of these examples, what's happening is it has the ability to absorb light, and it takes and it absorbs the light, but then what happens is it's able to actually release that later. So it's very similar to, it can be similar to fluorescent, where it can absorb ultraviolet light, and then it can actually emit it as visible light when it's combined with other chemicals in its composition. So your phosphorescent light is the things that absorb light throughout the day. They absorb light energy throughout the day, and they store it, and then at a later time they actually release it. So your glow-in-the-dark stars, things like that. Anything basically glow-in-the-dark that if I set it out during the day and in the light, it's going to absorb it and it's not going to glow. But then when when the lights are off, then it's going to emit that light as a form of energy. Okay, so that's phosphorescent light sources. And then the last one we'll touch base on is called chemiluminescent. So that's light energy released by chemical reactions. So I have chemical energy, and then it's being converted into visible light. Okay, so through an exothermic reaction, which gives off light or heat. But in this case, we have some chemicals inside our glow stick. Okay, we have a barrier in the middle. We have chemical 1 over here and chemical 2 over here. What happens is we bend this, okay, and we break it, and now we've broke this, and then we see the combination of these chemicals. When they combine, there's a chemical reaction that occurs, and then that's what causes this to emit visible light, which means give off light, and it glows. So these glow sticks work by taking two chemicals and barriers, breaking them, mixing it up together, and then that emits light through a exothermic chemical reaction. So it's chemiluminescent. So just to go through this really quick, we have natural light, things like the sun, things like candles, like fires. Bioluminescence, which is natural animals or organisms, living organisms that emit light, so jellyfish, fireflies. But then we have artificial light sources like incandescent light sources, which are very inefficient, but that seems to be what primarily we use, where you take electricity and it heats up a filament, creates white light, and then they produce 90%, 95% heat, and they only emit 5% light, but that's what we'll primarily see in our homes. Then we see fluorescent lights, which aren't used quite as much because the mercury vapor can be poisonous. But what happens is we take electricity coming in through pins down lead wires into electrodes, which then, in combination with the mercury, is actually vapors going to produce ultraviolet rays that are going to excite phosphor coating on the inside, which is going to emit a glow and light. They're very efficient, but they're expensive because they can be poisonous, so we have to be careful around them. And then we had phosphorescent, which was we absorb energy and then they emit energy, so that was your glow in the dark light sources. And then the last one was chemiluminescent, which was chemical reaction occurs where we have two chemicals, we break a barrier, mix them together, and the chemical reaction produces light. So anyways, that's light sources. I hope this has helped, guys, and we'll see you on the next screencast. Okay, thanks for tuning in. Bye.